Hi and welcome back to the channel. So in this video, I want to talk about how we can very easily add progress bars to our Jupyter notebooks or our Python applications using this library called tqdm. As usual, the full blog post with the Jupyter notebook, the whole code and all the links that I talk about here in this video are in the GitHub repo as a Jupyter notebook. You don't need to download anything. You can just view it directly in GitHub. It will show up properly formatted and so on, and the link is below in the description. So to install the library, we'll need to install tqdm. And if you're planning on using it in Jupyter, as we are here, you will likely have to install IPyWidgets as well. You can try without installing IPyWidgets, and then if you see some error messages when you try and use the progress bar in Jupyter, then you'll know that, okay, you have to go and install IPyWidgets as well. tqdm provides progress bars that we can use in console output, right? So let's say you're writing a Python application, not a Jupyter notebook, a Python application, and you want to put a progress bar on the screen, on the console, essentially. You can use tqdm for that. It will work just fine. For Jupyter, you can actually use a variant of tqdm that is provided that is specifically for Jupyter. And it just does things a little bit, it formats things a little bit differently. It makes it look nicer. It integrates better with the Jupyter notebooks. So I'm going to switch back and forth between using console and using Jupyter because you can use the console variant in the Jupyter notebook too. That works fine, right? So I will kind of switch back and forth to show you the differences between the two. There are some cases where you have to use the Jupyter variant, and I'll come to that later in the video when I show how to do nested progress bars. And so what we need to do is we need to import the tqdm object. That's going to be the main object we work with. So from tqdm, we're going to import tqdm. And this is what I'm calling the console variant. This is the one that you would use if you were using a console output. But if you're using Jupyter, you may elect to instead use tqdm from the notebook submodule. So from tqdm.notebook, import tqdm. And those tqdm objects are, functionally the same. You set them up the same way, you configure them the same way, they have the same parameters. It's just that the display is a little bit different. And I'll show you that in a few minutes. And that's it. Once we've done that, we're actually ready to start adding progress bars. And it's very, very easy. So right now, my last import was from the notebook. So this is the Jupyter variant. So let's look at the out-of-the-box functionality. There are three kind of default ways that these progress bars will work and are configured. And then later I'll show you how we can completely customize that, and it's very simple to do. So the first one is I'm not going to do any work in the loops. Basically, I'm going to time loops, right? I'm going to put a progress bar on loops, not time things. So from time, I'm going to import sleep. And then I'm just going to do a loop, right? For x in, let's say, the string Python rocks s. And then I might do something in here. And I'm just going to sleep so that slows down the loop a little bit. Okay, so that's my code. And I want to actually put a progress bar. I want to know as this thing is iterating, where is it at? What is it completed and where is it at? Well, it's very, very simple. You take your iterable and you wrap it inside tqdm. That's all you need to do. That's it. So now when we run this, we get the progress bar. And tqdm, of course, passes the iterator or the iterable back to the for loop. So you're not losing anything. You're just basically injecting, you can think of it that way, you're injecting the progress bar inside here. And you can see it's got a variety of components. It's got the percentage completion. It's got an actual display about, of the progress bar. It tells us how many iterations so as it's running, you can see it's telling us it's run 7, 8, 9, 10, etc. out of a total of 13. So basically it looks at this iterable over here. It looks at the length of the iterable, and now it knows what is the percentage completion? That's the first thing. It needs to know what's the total, right? It can display the total. It displays the elapsed time. And then here it also tries to calculate, as we're running this, the amount of time left to run. So it's kind of an estimate of, it's your ETA essentially. And then it also gives us here a rate, how many iterations per second, which, about 4 iterations per second is what we would expect since we're sleeping a quarter second inside every loop. So one thing to note here, is that tqdm basically queried our iterable to find out how many elements are in it. But this raises the question of, well, if I pass it an iterator, it can't do that, because if it queries the length of an iterator, it's consumed it, and now we can't loop through anything. So let's take a look at what it does, and I'm going to switch to the console output here just to show you that we can use either. So from tqdm, I'm going to import tqdm. So now this is the console version. We didn't import it from Notebook. And I'm going to basically type this. Actually, I'm going to copy paste it. So here I have a generator expression. So this is an iterator. You can only iterate through this thing once. This means that tqdm, if it tries to figure out the length of this thing, has just broken our code, right? So let's try running it and see what actually happens. Well, as you can see, the display is very different. It recognizes that this is an iterator. It cannot go and query the length of this thing. And so it doesn't try and tell you percentage completion. It doesn't try and show you a progress bar, but it just shows you the number of iterations. It shows you the total elapsed time, and it also tells you the rate at which this iteration is running. So that's great, right? We can still use that with iterators without breaking anything. And of course, you can also use the Jupyter version. So let's go ahead and do this. We'll use the Jupyter version, and that's a little bit different. So this is one of those differences I was talking about earlier. The Jupyter version kind of works, but it's in my mind, it's broken. I'm pretty sure this is an issue with the library itself that they'll fix at some point. I'm almost positive this isn't by design. But, for an iterable, it can't tell you what the maximum number is. For an iterator, it can't tell you what the max number is. And it can't show you a progress bar. And it certainly can't do an ETA. So the output really should have been the same as what you get with the console version. But that's really not a big deal, because I'm going to show you later, we can customize this completely to display exactly what we want. And it's very simple to do. So this is not a deal breaker by any means. Now, when we iterate over ranges, right, if we want to iterate over a range and put a progress bar on it, we can certainly do something like this. So I'm going to say for x in tqdm, let's say range, let's do 50,000. Well, let's do range 3, 100, 3, like so, okay? And then we'll just pass. Wow, maybe I should sleep a little bit, right? So let's sleep a quarter second in each one. So I can certainly do it this way, right? This works just fine. But this is such a common thing to do that there's another built-in object to tqdm that allows us to bypass having to do this and then tqdm and then range. Instead, what we can do is we can say from tqdm, and I'll use the Notebook version of this. We're going to import the tRange object. And basically, it takes the same arguments as a regular range, but it automatically adds the progress bar for us. So now we can just say for x in tRange, and then we'll do the same. So we'll do 3, 100, and 3, and then we'll sleep 0.25, like so. And so this gives us exactly the same functionality, right? It's just a little bit quicker. So this is the second way in which you can create progress bars. You got the tqdm object. You've got this specialized tRange object. When you're just iterating over a range, you may as well use it. And then lastly, we also have a way of manually updating the progress bar. I'm not going to spend too much time on it. Take a look at the documentation. It's well explained. There's lots of different things you can do. And at the end of the video, I'll explain some of the other features too related to manually updating the progress bar. So to do a manual update on the progress bar, we need to basically create the progress bar ourselves and then update it as things change. And we can configure it, we can give it all kinds of different configuration options, and then we just have to update it. But we have to create it. And this is just like with a file. When you open a file in Python, you need to always remember to close the file after you're done with it. What's the easiest way of not forgetting to do that and having robust code that will close the file even if an exception occurs? Use a context manager. Well, tqdm provides you a way to create a progress bar and then close it later once it's done manually, or you can also use a context manager. And unless your code really requires you to be able to create the progress bar in one place and then close it somewhere else, use a context manager. It's easy and it's safe. So let's go ahead and do that. So I'm going to go back to the console version, let's say. It doesn't matter, just switching back and forth just to change up. So I'm going to import tqdm. And what I want to do is I want to create this progress bar. All I need to do is say with tqdm, and I'll pass no arguments here, and that context manager will return the progress bar. So now I have a handle to the progress bar that was created. Now I can do whatever I want. I can say for x in, let's say Python rocks, and I'm going to sleep 0.25 seconds. And now I'm going to send an update. I'm going to say update by 1, increment by 1, essentially, my bar. So when I run this, let's see what we get. Well, as you can see, we get the iterator version of the bar. Well, yeah, because this bar knows nothing about what the, how many iterations are we going to perform. But that's very easily remedied. We can actually tell it. We can say, we can basically take this same code. And then what I'm going to do, so I don't retype that string twice, I'm going to call this the iterable equals this. Now what I need to do here is I need to pass it some arguments. And I'll show you more arguments with tqdm. The argument I'm interested in here is called total. This is going to tell the progress bar what's the total number of iterations. Well, this is just the length of the iterable, right? And then here we're just going to iterate through the iterable itself. And now we're going to get our regular progress bar with the percentage completion, with the estimated time left, and so on. And of course, you have the same thing if you want to use in Jupyter. You can do that as well. It works the same way as I mentioned. So let me actually show you the all the parameters that you can specify with tqdm and trange are the same whether you import it from tqdm or from Notebook. Right? Identical. It's just that the display is a little bit different. Now, another thing that we can do is with this manual approach, we can set the description. And there is no description right now in this progress bar. And I'll show you more customizations later. But let's say I want to add a description here and it's going to go in front. So all I need to do for that is I need to specify that I want to set my description. Now I'm in manual mode. So I'm going to say pbar.set description, and I can set it to whatever I want. And in this case, I'm actually going to make an f string that's going to contain the element x that I'm iterating. So I might say processing x, right? And this might be what I want for my description, like so. So now if I run this, you'll see it's telling me processing that. I probably don't need to add the extra colon. Okay, so it's pretty simple to do a manual progress bar as well, where you can go ahead and you don't have to update by 1. You could update by more if you wanted to. It depends on what you're tracking and so on. And I'll mention that in the conclusion as well, but there's a lot of other functionality too, where tqdm provides callback methods that you can register, or even hooks, so you can hook into the progress bar from other places. So it's very, very flexible. I'm not going to actually show this in this video. I want to keep it short and kind of give you the, kind of the 80-20 of using this progress bar. So in that light, let's move on to customizing things. So the behavior and display of the progress bar can be customized in many different ways. Take a look at the documentation. It has a full, range of options. They're pretty well documented. So go ahead and take a look at that to see everything that's available. Here I'm only going to talk about a few things. So one of the things you can do is you can customize the width of the bar, for example. You can change the scale of the iteration count. You can change how the progress bar displays the various sub-bars, like this part over here and this and this. All these are basically, you know, we can customize that entire display. So I talked about scaling. Let's talk about scaling first. So I'm going to go back to the regular console version, and I'm going to just write this. I'm going to say for I in range in tqdm. So I know I could use trange, but I want to show you how we can customize tqdm. So I'm going to iterate 50 million times, right? And I'm just going to pass. I'm not actually going to sleep because this will take too long. But let's look at what happens. Well, we get what we expect, right? The only thing is that this is a pretty big number, right? 50 million. It's difficult to read, and it would be better if we could change the scale to say 50 million maybe, you know, things like that, or 50,000, 50K, 50M, those kinds of things. And tqdm supports that using auto scaling, and that's what we can do. And it's very easy to do. All we need to do is to go in here and add a named parameter called unit scale, and we can make that equal to true. And now look what happens. You can see it's now giving us this 30, point something million out of 50 million, right? It's rescaled, and it will automatically rescale. If we do 50,000, let's say, and this will probably go too fast, but it doesn't matter. You can see it's using a K for the thousands, and so on. Now, one of the things too is I may want to change the unit name, because the unit name by default is IT for iteration, right? It's counting iterations. But we can change that if we want. All I need to do, and let me go back to 50 million. So we can change the unit name to something else. I'm going to change it to record, for records maybe, right? And so you can see that this description here of the unit name has now been updated to rec. And we'll see how this ties into, fully customizing everything else on this line. We can also change the bar color. That's very simple as well. All we need to do is just specify color. And we can use either a named color, like the known names that tqdm knows. So we can make a blue bar, or we can use the just hex code. So we can say pound or hash ff0000, like so. And now you get the red bar, right? So you can use whatever you want for coloring the bar. So now what about all these displays here, right? It's this progress bar number, this percentage completed, this unit that's been scaled, the total elapsed time, the estimated remaining time, the speed, the name of the unit and where it's placed, and this per second, right? We can customize all of that. Now in the notebook, I have a list of all the possible fields that we have available, all the possible variables that are available from tqdm. And basically the way that you customize this is by providing a format string that's a pure Python format string, just like you would do with an F string, or if you had a string where you're going to do a format. So what I mean by that is something like this, right? So we could say we have A equals, and then we'll put in A, and then B equals, and then we'll put in maybe var2, right? Just to change things up. And now that string, right? So if we make that our format string, we can now go ahead and format it, and we can pass it the values. A equals 100 and var2 equals, let's say, 20. We can do something like that, and it interpolates it, and we get that, right? So this is what I mean by the Python format string. A was a variable, var2 was a variable that got passed in during the formatting. So in tqdm, there are a bunch of these variables that are available that we can use in our format strings. And let me go ahead and copy paste them from the notebook, so we have them here. Just want to show you. So we have all of these. We have L bar and R bar. We also have bar, which I didn't add in here. I should have. But the way that this by default is formatted with tqdm, it is L bar, R bar, with then the bar and then the right bar. And then I think it adds in these pipe characters as well inside L bar and R bar. And L bar and R bar themselves are made up of these other fields. So you can certainly reuse L bar and R bar and you'll get exactly these things, right? So you could technically reuse that, or you could completely ditch L bar and R bar and only use all these fields over here. So let's take a look at some examples. So the first one I'm going to do is I'm basically going to want to do a progress bar where I have the left hand side, I have the progress bar itself, and I want nothing on the right hand side. Well, I can just basically use L bar and not use R bar. So what we do here, and you'll see I'm changing the description. So that's going to be a fixed description for every iteration, but it's going to show up to the left of the progress bar. I'm changing the color bar to blue. And then for the bar format, I specify this format string. So I want the left bar and I want the bar itself. Now when I run this, you'll see we get what we expected. We get the description showing up here, right? And because the description is part of L bar, right? And we'll break that down in a minute. And then you'll see there's nothing to the right of the progress bar because I didn't include it here. Okay, so let's get a little bit more fancy. Let's actually use the base fields themselves. So again, I'm going to change my description, set my color. Now I'm going to also set my unit scale to true, right? And then I want to change my unit name to Rex. And then for the bar format, here's what I have. I'm going to put in the description, then a pipe character, and then I'm going to say processing n of, total. But I don't want the raw n and the raw total. I want the scaled n and total. In this case, I'm setting unit scale to true, so it will come back as, 50m or 50k or whatever it is, as in auto scaled. I also want to add the unit name right here. Then in square parentheses, I'm going to want to put the percentage completion, and I want it to be a 0.1f, right? So it's going to be a float, 0.1. Then I'm going to put in the percentage sign. All this is just text characters. Then I'm going to interpolate the bar itself. That's the display. I want it. Maybe you don't want it, but here I want it. Then I'm going to put another pipe character, and then I'm going to put in the elapsed, which is going to tell me the elapsed time. And here I'm going to specify as a text character what the units are of this elapsed time. And that's it. We've basically completely redefined the format of our progress bar. And you can see it's doing that exactly. Now, of course, as I've mentioned, and let's just test this out, all this works perfectly fine with the Jupyter version as well, right? So we can say from tqdm.notebook, we're going to import tqdm. And then we're going to use the exact same code we had before, no changes. And you can see it works perfectly fine in the Jupyter notebook. Now, one thing that you probably noticed as it was running is that the progress bar kind of keeps shifting around a little bit. You can see how things are shifting around. And this is because of the font that I'm using in my Jupyter notebook. I'm using a font that is not monospaced, unlike the font that I've defined for my console output, which is monospaced. Here it's not. So basically it means that the spacing between characters changes slightly depending on what the characters are. And that's why you see this thing shifting around a little bit. If you don't like that, as far as I can tell, the only way to fix that is to actually set up your Jupyter configuration to use a monospaced font for these output values, these output cells. So we can basically, completely customize what we want our bar to look like. But having to do this again and again and again, everywhere in our code, especially if we're doing, essentially the same formatting, we want to define this bar format and we want to keep it the same all the time. Maybe I want my description to be the same all the time, the color or whatever, right? And I don't want to have to retype all this stuff every time. So it's a very simple solution. We can use currying, so we can use the partial function that's available in plain Python. This has nothing to do with tqdm, and we're basically going to use it. So from functools, we're going to import partial, And I'm going to create essentially a new function that's going to be based on tqdm, but pre-populated with certain of the named arguments. And I'm just going to copy paste it here. Actually, you know what? I'm going to take this over here. That's what we need. And I'm going to say, well, this is my import progress bar. That's what I'm going to use whenever I do imports. I'm going to do that. And I'm going to make that a partial. And we're going to take the tqdm, right, which is the one right now. Which one? Well, that's the one from Jupyter, right? So I'm going to take that tqdm object as it stands right now. And I'm going to give it, I don't want the range. That will pass in later, but I want to basically pre-populate, predefine all these other values here. And so that's our partial function. So now import pbar is just a function that we can call, and it will be based on eventually the tqdm function or class or whatever it happens to be. And then it will also pass in those things plus whatever I'm going to pass here. So now it's very easy to use. We can just say for x in, and I'm going to say import pbar, and now I'm going to pass it the range, 50 million, like so. Okay, and so we get everything that we had before, but now we can reuse it as many times as we want, and we don't have to go through and redefine all those things every time. But again, this has nothing to do with tqdm, that's just Python, right? Okay, so the next thing that I want to talk about are nested progress bars. And all the examples I showed you appear to work fine in the REPL, like this Jupyter notebook. However, not everything that would work fine in the standard console output, which is what we've been using, back and forth here a little bit, will work quite as expected in Jupyter. So if you try and use the console output version for certain things, in particular for nested progress bars, that will not work in Jupyter. It will work fine in the console, not in Jupyter. For that, you have to use the Jupyter version. So let me go ahead and show you what I mean by nested bars and why we have nested bars. Well, here I have a nested loop, 3 levels deep. And I want to put a progress bar on K, I want to put a progress bar on J, and I want to put a progress bar on I. And I'll talk about what leave means in a minute. So let's go ahead and run this and see what happens. So now this is using the console version. And you can see that is not working correctly, right? It's basically putting all these bars, it's not clearing them out. Now, in part, we can try and fix that, and we have to, when we're even in the console, by using this argument over here. So let me just show you first how it looks like when you use the notebook version of trange. And the same applies with tqdm, by the way. So when you do that, you can see that this is a lot better, right? Let me actually go and set that to 5, and then 5, and then 5, okay? So you can see that now this is working correctly. We're getting our nested progress bars. So this is a difference where you really have to use the Jupyter version of the progress bar. Now you'll notice that once the progress is finished, all the sub bars, all the sub progress bars have been removed. And this happens because of this argument here, leave equals false. Leave means, do you want to leave the progress bar on screen once it's completed? If the answer is yes, then you just don't specify this because leave is the default, right? You can see that this final bar for I would remain there. If I specify leave equals false, then as long as things are running, it's going to get displayed. And then if we wait for this to finish, then we'll see that the I bar is also going to disappear now. You can see it's gone, right? So that's probably not what I want to do. I want to leave it on to show that the entire process has finished. On the other hand, I do not want to specify true, let's say, for these things, because then look at what happens. Because remember, every time, for every iteration of I, it's going to create a new trange object and then do a progress bar for that object. But now for the next iteration of I, do we really want to leave the old progress bar for J in place? No, we probably want to remove it. Otherwise, they're just going to stack up. And let me show you that's indeed what's going to happen. You can see that for every iteration of j, the bar is not getting removed. It's stacking up. And that's probably not what we want, right? So in this case, I want to set it to false. So I have to explicitly set it to false, and then we get our proper behavior. Okay, so that's it for this library. I find it very useful. It's very easy to use, and I can give users of my Jupyter notebooks or my code an indication that things are running, right? There's nothing worse than having a long-running process somewhere that doesn't give some kind of feedback to show that it's working, right? People start thinking the thing crashed, something's gone wrong, right? So you want to give some visual feedback of some kind that no, things are running, just be patient. Progress bars are ideal for doing that, and now you can even include them in your Jupyter notebooks if you want to. Now there's a lot more to this library as well that I haven't touched on. For example, it's thread safe, so it will work properly with multi-threading. It's async aware. If you're using async IO, you can also use these. Of course, you can use them in CLI style applications or regular Python apps where you have a console output. You can use those there as well. And then you have even more advanced features like callbacks and hooks. So you can actually have the progress bar call back, let's say, some external function, and then you can do other things with it. Or you have hooks that you can actually hook into the progress bar and change things as the progress is happening. And this is probably more useful for things like with async or multi-threading, where you can really leverage that really well. It also has native integrations with pandas. So let's say in pandas you have a big data frame, you do an apply, and you want to give some kind of feedback that, yeah, this thing is running, and have a progress bar. Well, you can. It integrates with pandas as well. It also integrates with libraries like Keras and Dask, and a few others as well, obviously Jupyter, as we saw today. So it's a really, really powerful library. It's very simple to get started, but it's also very flexible and has a lot of extra features should you require them. So hopefully this is useful, and maybe you'll find this particular progress bar library useful. Thanks for watching, and I'll see you next time.